Right, so I'm just going to do a few questions. I won't do too many because this is the section where there's a fair bit of memory recall in name this, name this. Python is an example of which, and you put high level language, blah, blah, blah. But I'm just going to go through the main things. So describe what two key factors affecting what type of translator a programmer would choose. So basically the two types of translator are compiler and then the other one is an interpreter because they're the two. So basically it's saying why would you use one of these? So what are the benefits? Well, basically a compiler, it allows for optimized running of the program once executed. So if it was important the program ran very fast when it was executed, like a game, for example, because you've got no idea what experience it'd be like if you interpret the game as to at the end. And one thing about an interpreter allows optimized code running of the code. So if this was important, then a compiler would be the choice. If they are in the development stage and feel they will be executing the program a lot, then an interpreter would be far quicker and easier to use. Something like that. And then spell check. So that's basically it. I'll say one good thing about a compiler, and if that was, but don't just say the reason. Don't just say compilers. Here's a good thing about a compiler. Say, so if it was important, this was important, then do this. If they're developmental stage, they'll be executing the program a lot. Then interpreter will be far quicker to use and easier. As the program executes, doesn't need compilation time. That's why it's faster, by the way, to run. If I didn't mention that before, is that there's a time to compile a program, before you run it for a compiler. An interpreter doesn't have that. Right, describe the role of compiler. So a compiler is needed to convert a high-level language code, such as Python, into machine code. Now, that's one mark. You're thinking, but what? That is it. The reason we need to translate it into machine code is that is the language that the C computer or CPU can actually execute. And then because it's a compiler and not a translator, I would also just think, I don't think I need to, but I'd be like, right, I'll make sure that I've said compiler. A compiler converts the whole program into machine code before executing it. Just make sure you're getting your marks. Yeah, so I've written sort of basically three things there. Let's make sure. Bang. Name two features of an IDE. Not very difficult. Just basically list all the things that are in here. Any of these. So I'm going to say an IDE helps the programmer by auto-completion of the commands and variables. It also highlights keywords in specific colors. Now, I know it says two. I might even be tempted to write like 1, 2. It'll probably have that in the test. Colors as well as bracket matching. And let's just make sure we get the marks. There we go. I've listed a few. So yeah, this one's not too bad. Just make sure you understand the main gist of this unit, just very briefly, in a nutshell, is to understand that high level and low level, in the end, everything has to go to machine code. From assembly, it's assembled with an assembler. From a high level language, it is compiled or translated. So that's what you got to understand. And it's quite obvious. Like, why is it better to write in a high level language? Well, it's easier. Like, it's easier to understand. It's easier to debug. It's quicker. Like, writing that program might be hours in here. And you might get lost. Look at that gibberish. Right? So you're never going to be able to find any errors. Done about 4th gen, obviously. So you translate it. You need to... A compiler compiles the whole lot in one go. And that takes time. So that's called compilation time. But then the code is optimized and it's normally used at the end. And the source code is safer because it's no longer in words. Like if you send someone a program and it's interpreted, you're basically sending them your source code. Like you're literally sending them this. Hello, they can look at it. Now, this is not good if it's an app, because then they can see exactly how you've done things. They can steal bits out of your code, and they can look for any ways to sort of break your code. If I make this into an exe by creating it into an executable, build, there we go, build solution. If I build that, you'll actually see at the bottom here that it's built it to an actual exe that I can, if I delete this and take off the breakpoint, I can actually run that program from that app. There he is, it's in there. If I go to that folder, there'll be an actual exe that I can run. There you go, application, run it. Now, annoyingly, it doesn't. It will flash up and down really quick because it doesn't pause. So let's. If I really wanted to demonstrate it, I could just read a line. I'm just gonna have to do string s equals. What's the error I've got here? As also, I never use the console either to read a line. Read line. Maybe I've got to put something in there. Maybe I don't put anything in. No, I don't. Right, there we go. So build solution, then run it, and then read line allows me to stop. So there you go. So now that the point is that over here, sorry, I've moved it off the screen. That is what I would send to people. So they wouldn't see any code. They see a 171K executable file, and they can't find out what I wrote. But look at that. That is 171,000 kilobytes. 1,000 bytes. That's a lot for a program that writes to the screen. So you can see these things like C# and others, they bulk it up. Now, you know, they bulk everything up. So, you know, that's a lot of commands. But there you go. That's just going through that unit quickly.